Have you ever wondered how to debug your Arduino code or see what your board is actually doing behind the scenes? In this video, we will explore exactly that. We are going to learn how to use the serial monitor, a simple but powerful tool for communication and debugging. If you are new here, welcome. This is lesson number 8 of our 24-part series called Arduino for Beginners. The serial monitor is one of the most essential tools in the Arduino environment. It allows you to communicate directly with your board in real time. You can use it to display sensor data, debug your logic, and even send commands to the board from your computer. If something is not working in your project, or you just want to understand what your Arduino is thinking, the serial monitor is your best friend. In older versions of the Arduino IDE, the serial monitor would pop up in a separate window, but with Arduino IDE version 2, things got a lot more convenient. It's now integrated right into the editor. You can even open multiple monitors if you're working with more than one sketch at the same time. Today though, we'll be using the Arduino Cloud IDE, so go ahead and open it in your browser and create a new sketch. On the upper right corner of the screen, you'll see an option labeled Serial Monitor. If it's grayed out, that just means your board isn't connected yet. So grab your Arduino, plug it into your computer, reload the page and wait for the IDE to recognize the board. Once it's connected, you'll be able to click on the serial monitor. At first glance, it might seem like a boring, empty window, but don't worry, it will start to make sense when we use it in a real-world project. Before we jump into the hands-on part, I would like to thank DF Robot for sponsoring this series. If you don't know them yet, DF Robot is one of the leading companies in the open source hardware space. They create high-quality, affordable components that are perfect for makers, students, and hobbyists. They kindly provided me with the Mind Plus Arduino coding kit, which comes packed with sensors, modules, cables, and more. Everything a beginner needs to build cool and meaningful projects. It's the kit we are using throughout this entire course. If you want to follow along more easily, I highly recommend checking out. You'll find the link to DF Robot store in the description. Thanks again to DF Robot for sponsoring educational content like this. Alright, let's put the serial monitor to use with a hands-on project. We're going to connect an ultrasonic sensor to the Arduino and display the distance readings directly on the serial monitor. This will give you a practical idea of how to visualize sensor data and debug your projects in real time. Start by plugging the ultrasonic sensor into the input-output expansion shield and then connect the shield to your Arduino board. If you need help wiring things up, here's the schematics. Next, open the GitHub repository linked below and copy the code into your sketch. Now I'll explain to you what it does. First, we define some variables. If you don't know what that means, I recommend you watch lesson 6 in which I explain several coding concepts. Then, on the setup function, we added a new command, serial.begin 9600. This will start the communication between the board and the serial monitor. The number inside the parentheses is the baud rate, in other words, the speed in which this communication happens. 9600 is the default value. We are using the ultrasonic sensor to determine the distance of any object close to it. There is nothing new here, but in the end, we added a bunch of serial.print commands. This means print a message on the serial monitor. By the way, the serial.println means print a message and go to the next line. This way, the readings will appear one below the other. If you open the serial monitor, it's exactly what you see. If you need help understanding how ultrasonic sensors work, I posted a tutorial about that in this channel. Don't forget to check it out. Another interesting application of the serial monitor is to send data to Arduino. You'll see this working closely in the next project. So create a new sketch and copy and paste this another script. As always, it's available on the GitHub repository of this series. Link is in the description. This new sketch will allow us to turn on and off two LEDs connected to the Arduino by tapping words on the serial monitor. To accomplish this, you need to attach the red LED on pin 5 and the blue LED on pin 6. You can refer to these schematics to help you assemble everything. This is a really nice sketch. Upload it to your Arduino and then open up the serial monitor. As you can see, there is a typing bar. We can use it to send data to Arduino. In our case, if I write down LED red on, the red LED turns on. Now, if I write LED red off, this turns off the red LED. I can do the same with the blue LED by typing LED blue on or LED blue off. It's also possible to control the brightness of the LED by informing a value from 0 to 255. 0 means no brightness and 255 means full brightness. So if I type LED blue 127, it turns on the blue LED with half of its brightness. If now I type LED blue 255, the blue LED lights up with full brightness. In the opposite way, I can type LED blue 0 and the blue LED turns off completely. Pretty cool, isn't it? I highly recommend you write down some commands and test it by yourself. Now let's take a look at our code and see how it works. The beginning and setup function is very similar to the other sketches, so let's move on and focus on the loop function, the heart of our code. Inside this loop, we first check if the user has typed anything into the serial monitor using this line. If the data is available, we read the full line until the user hits enter and store it in a variable called input. Next, we clean up any extra spaces from the beginning or end of the text. Now we try to break this input into three parts: the command, the color, and the value. For example, if the user typed LED red on, we want to separate it into LED, the command, red, the color, and on, the value. To do that, we look for the position of the first and second spaces in the string. If both spaces are found in the right places, we extract the command, color, and value using the substring function and convert them all to uppercase so we can compare them more easily. Now comes the decision making. We check if the command is LED and if the color is either red or blue. If it is, we figure out which LED pin to use. Then we look at the value. If the user typed 1, we set the brightness to maximum, 255. If he typed off, we set it to 0, turning the LED off. If they typed a number between 0 and 255, use that number to set the brightness level. We use the analog write function to send the brightness value to the LED pin. Each time a valid command is received, we print a message confirming the state has been updated. If the command is wrong or mistyped, we tell the user the input was invalid and ask them to try again. This logic allows us to control LEDs using just plain text, like LED blue 150, directly from the serial monitor without pressing any push button. That's it for today's lesson. I hope you liked and learned a lot about the serial monitor. This class ends the second module of our Arduino for Beginners series. This means we've built a solid foundation about electronics and coding. Now you are prepared to move on and build more complex projects. From now, you'll learn about every component that comes with the Mind Plus Arduino coding kit until lesson 24. If you enjoyed it, please like and subscribe so YouTube recommends this to other viewers. Thank you so much for watching this class. I will see you in lesson 9 come very soon.